In the mysterious depths of human development, few processes are as intricate and captivating as the formation of the fetal heart. This miraculous transformation begins just 18 days after fertilization, marking one of the earliest and most crucial events in embryology. Long before the brain can fathom thought or the lungs take their first breath, the heart embarks on its journey to become the central powerhouse of human life. From the mesoderm layer, a population of specialized cells migrates to a small, seemingly inconspicuous area known as the cardiogenic field. This region, lying just ahead of the developing head, quietly holds the blueprint for the future heart. Within this field, the cells organize into two delicate strands called the endocardial heart tubes. These tubes, though barely visible, are the precursors to what will become the heart's elaborate architecture. As the embryo undergoes a series of folds, these endocardial tubes fuse to form a singular, primitive heart tube. This tube, albeit simple in appearance, consists of three distinct layers that will each play a pivotal role in the heart's development. The innermost layer, the endocardium, lines the heart and forms the basis for the heart's valves and internal structures. Surrounding this is the myocardium, a robust muscular layer destined to generate the force necessary for pumping blood. Encasing the entire structure is the epicardium, which will eventually give rise to the coronary vessels, ensuring the heart's own nourishment. Around days 21 to 22, a remarkable event occurs. The primitive heart tube begins to beat with a rhythmic precision, an astonishing feat given the absence of nerve connections at this stage. This autonomous heartbeat is driven by specialized pacemaker cells, orchestrating a tempo that will sustain the embryo as it grows and evolves. As the days progress, the heart tube, initially straight, begins to undergo a process known as cardiac looping. This dramatic bending and twisting to the right is not random, but follows a highly regulated sequence. This sequence will determine the future anatomical layout of the heart's chambers. Cardiac looping is a critical juncture as it establishes the spatial arrangement of what will become the atria and ventricles. Following this looping phase, the heart's internal structure becomes increasingly complex. Walls known as septa start to form, methodically dividing the single-chambered heart into left and right sides. This division continues, further partitioning the heart into four distinct chambers: the left atrium, left ventricle, and right ventricle. The transformation does not stop there. Within the heart, specialized swellings of tissue, called endocardial cushions, emerge. These cushions are instrumental in sculpting the atrioventricular valves and semilunar valves. They ensure the unidirectional flow of blood through the heart. Concurrently, the large outflow vessel, known as the truncus arteriosus, undergoes its own metamorphosis. It splits and spirals with meticulous precision to form two major arteries, the aorta and the pulmonary artery. This step is so critical that even minute deviations can lead to congenital heart defects. Despite its growing complexity, the fetal heart functions in a manner vastly different from its adult counterpart. During fetal life, the lungs remain non-functional, with oxygen supplied directly from the placenta. To accommodate this unique requirement, the fetal heart employs specialized bypass pathways. The foramen ovale, a small opening between the right and left atria, allows blood to circumvent the non-functioning lungs. Meanwhile, the ductus arteriosus diverts blood from the pulmonary artery into the aorta. It efficiently directs oxygen-rich blood to the brain and other vital organs. This intricate system permits the fetal heart to maintain a rapid pace, beating at an astonishing 120 to 160 beats per minute. It continues to adapt, accommodating the growing demands of the developing baby. Yet, as the heart approaches its final stages of fetal development, it remains poised for monumental changes at birth. A transformation will see it switch from a fetal system to an adult circulatory pattern in the blink of an eye. However, this dramatic shift awaits the very first breath. This signals the closure of fetal shunts and the beginning of a new chapter for the heart, a true marvel of biological engineering.